In today's lesson, we're going to be learning the slope formula. So, in the past, we've been focused on finding slope by looking at a graph and counting the rise and the run. And there's absolutely nothing wrong with that, except for the fact that if you don't have graph paper, it's really hard to do that. And there is a much easier way than trying to draw out on a graph if you don't have graph paper. Or what if you're dealing with really, really big numbers that don't easily fit on graph paper? So I want to give you some options. The easiest option is known as the slope formula, and I'm going to introduce that to you over the next few minutes. So pick up your pencil, make sure you have paper, and make sure you're taking notes. Yes, this is another formula that you need to have at you need to be able to access it quickly. So you need to be taking notes, and you need to be working on putting that in your memory banks. So this is actually the exact same line we just worked with earlier, because I want to show you how this formula works. In blue, you see how this question would look if you weren't given a graph. You would just have, find the slope of the line that passes through, and the 2 points that I have marked are the 2 points I used in the warm-up, -3, 1, and 0, -3. Now, if by chance I did not have the graph, there is a way for me to figure out that the vertical distance is indeed -4, just like I counted before. It's actually really easy to do, too. Take a look at the points we have. The y values are 1, let me choose a bigger highlighter there, and -3. If you take your y values and you subtract them, so you do, and I'm going to go in this, well, no, I'll do it like this, 1 minus -3, you get 4, don't you? Now somebody's saying, yeah, but Miss Creasy, that's giving me a +4 instead of a -4. Well, relax. It'll be okay here in a moment. Back earlier, when I was counting my slope, I was counting the run this way, and that was a +3. If I didn't have the graph, I would instead take my x values, and I would do -3 minus 0 to find my run. What's that giving you? -3. Remember, these were my y's, so that's my rise. These were my x's, so that's my run, because this was going side to side. The y's would be the up and down, and I'm still getting -4 thirds. The cool thing about this whole subtraction deal is it really doesn't matter the order you do it in. It just made sense the way that I had the problem written here to do the number on top minus the number on bottom. But if I flipped it around and did it this way, -3, this y minus that y, for my rise over my run, this x minus that x, so 0 minus -3. Now let's see what I get. I'm going to do keep change change, so -3 plus -1 is -4. 0 plus +3 is 3. Hey, it's still -4 thirds. That, everybody, is the origin of the formula you're about to see. That's all that this formula is doing. But some people get nervous when they see formulas and they see variables, especially since in the formula, well, think about it. We've got 2 ordered pairs here. This ordered pair is an x and a y, and this ordered pair is an x and a y. So it's like you got 2 x's and 2 y's, and whoa, that can get really confusing really fast, but don't worry. What happens is the first pair has a little subscript, a 1 by its x and a 1 by its y, and the second pair gets a subscript of 2 by its x and y. And that is why what you see in the formula here is y1 minus y2 and x1 minus x2. sometimes you might see it written this way. And the key is it really doesn't matter which pair you put first when you subtract, just as long as you always put the same pair in front. So remember, the ordered pairs that go into this formula would be an x1, y1, and an x2, y2. Those would be my points. So please make note of the fact that if I started with the y1 here, I put the x1 here first. If I start with the y2, I'll put the x2 first. But it doesn't matter which point I put out in front. What really matters is that I always put the rise on top, the y's. When I'm subtracting my y's, I'm finding the vertical distance. So that's in line with the y-axis. And one thing that always helped me, because I knew about direct variation before I learned slope, is I remembered that when I had that formula for direct variation, it was y over x, and the slope formula does the same pattern, the y over the x. All right. So in my mind, there's really no better way to figure out what we don't yet understand about the slope formula except by giving it a try. So let's find the slope of the line that passes through the points 5, 8, and 1, 2. So we're not going to use graph paper. You can use Desmos if you need to check your subtraction at any point. So only 2 arithmetic skills you're going to need are to be able to subtract and possibly to simplify a fraction when we get to the end. So if you're feeling confident and want to give it a try, go ahead and hit pause. If you'd like me to set up the problem before you try, stay online. So when I look at this, I'm like, okay, I've got a 1 pair, so this is an x1, and this is a y1, and I've got a 2 pair, an x2 and a y2. Do you remember your formula? Did you forget to write it down? All right, I'll give it to you for free this time. Slope formula is, and students have always told me they like it better this way, so y1 minus y2 over x1 minus x2. Okay, now, I really do want you to try your hand at substitution. So if you look over here, I've identified already what x1, y1, x2, y2 would be. Your turn to substitute them in their spots in the formula, to do the subtraction, to look at your answer and see if it needs to be simplified. Those are the remaining steps. So please hit pause and give it a try. Let's see if you can do this. All right. How confident are you with your answer? If you don't have an answer yet, I really do want you to give this a try. We're not doing enough of them that if you don't understand, you're going to be learning it wrong. I want you to see where you're getting stumped, which means you got to try something first. Okay, so I really hope nobody was stumped with, okay, this underneath my y1 is 8. It goes in the first spot. And then minus y2. Okay, that's a 2. Over x1, that was a 5. Minus x2, that's a 1. All right, how are we doing so far? Is that what you have? So now all I have to do is subtract. 8 minus 2, that's 6. 5 minus 1, that's 4. Okay, 4 does not divide evenly into 6, but I can, in fact, I need to, simplify those fractions. So I can divide them both by 2. I said fractions, I meant the fraction. So that's going to give me 3 halves. Final answer. Now, let's say you were somebody who did this on your own and you, like I usually do, wanted to do it in the reverse order. You did the y2 minus y1 over x2 minus x1 version because, well, you just felt like being different. Well, that would just mean y2 2 goes first, minus 8, because that's the y1, x2 is 1, and 5 is x1. All right, I'm going to do a little keep change. And when I do that, I get negative 6 over negative 4. The negatives would cancel out because negative over negative is positive, and I still get 3/2. So nobody needs to stress out over which to go first, which one goes first. You just have to be aware that if you do the y1 minus y2 on top, you got to do the same thing on the bottom. Sometimes I'll even draw it out on my paper, let myself know, oh, I did y1 minus y2, therefore I have to do x1 minus x2. So those are some options to keep everything straight. Let's try another one. This time, everybody should have that formula written down and an example on their paper already. So you have that to refer back to. So please hit pause and give this a try on your own. Okay, so I'm only going to do it one way this time. If you did it the other way, you should be getting the exact same answer. So if you don't, something went wrong. So I'm going to do y1 minus y2 on top, and x1 minus x2 on the bottom. I'm going to go ahead and label them since this is your first day seeing this. That would be my first x. This would be my first y. Here's my second x. Here's my second y. Remember, all ordered pairs consist of an x and a y. So, next step, fill in the formula. y1 is 3 minus y2 is 12. x1 is negative 9 minus x2 is 6. Looks like I'm going to be doing some keep change. And that's going to give me negative 9 over negative 15. Well, that's a proper fraction. But I do know that negative over negative is always positive. And both 9 and 15 can be divided by 3, so that's going to give me 3/5. There's my slope. How did you do? If you did not get 3/5, are you able to go back and see why not? If you can't, that would be a good time to send me a message so I can take a look and see what might have gone wrong. Let's do one more. Same deal. Please hit pause and give this a try on your own. Okay, how'd this one go? I'm going to write the formula out again. One of the reasons I'm writing the formula out is rewriting something is one of the best ways to help put it in the memory banks, to, memorize it. And that is something you're going to need to do with this formula. Okay, so negative 4 would be playing the part of x1. 10 is playing the part of y1, so that's my 1 pair. My 2 pair, 3 is x2, 5 is y2, which means that I start off with 10 minus 5, y1 minus y2. Then it's x1 minus x2, so negative 4 minus 3. Little keep change. That's giving me 5 over negative 7, which is basically just a single negative 5/7. Can't simplify that at all. And there you go. So next step in the lesson is to get a little practice with this whole formula. And for that, I'm going to be sending you to IXL today. Like I said before, if you've got questions, I want to hear from you through messaging or email. I'll take either.